Chapter 8, Question 6, a similar problem to Question 5. This time the data deals with a number of credit cards that people have, and again they're broken down by gender, male or female. So the first question we're asked here is, what is the probability if from this group of people we were to randomly choose someone, what's the probability that they had 0 credit cards, didn't have one? Again, we look for the ratio of those who had 0 credit cards divided by the total possible outcomes, which is all the people. So those with 0 credit cards, the total is 27. The total number of people, total of the total, is 81. There's our probability. But again, you won't see that number in the back of the book, but this can be reduced. Let's see, 3 goes into both of these, right? Yeah. Oh, but 9 also goes into both of these. So 27 divided by 9 is 3. 81 divided by 9 is 9. Oops, I can reduce it further. 3 goes into both of these. So if you spotted that 27 actually, I guess, goes into both of these, you would have been ahead of me, but I'm going to get there anyway. 3 divided by 3 is 1. 9 divided by 3 is 3. This is our probability, 1/3. Turning it to a decimal, we get 0.333. Turning this to a percentage, multiply by 100, we get 33.3%. So about a chance, a third chance. 1 out of 3. That's it. The B question, we're going to use that formula again because we want to find the probability that a person chosen at random has at least 1. Now this is another way to ask sort of the person doesn't have 0, not 0. At least 1 is at least 1, 2, 3, 4, 5. It's anything but 0, right? So in this case, probability at least 1, we can use that formula again. Instead of counting how many had 1, how many had 2, how many had 3 and 4 and so forth, although it's not too hard in this case, we can take 1 minus the probability that they had 0. Okay, a little bit of thinking here, but that's what they're saying. They had 0 credit cards. They don't have 0 credit cards. They have 1 or more. The cool part is we've already solved the second part here. Probability of 0 is here. Why go through all this work again when we can just use it? We know the answer is 1/3, so it's 1 minus 1/3. The way we write 1 is going to be 3 over 3, so we have a common denominator. 3 minus 1 is 2/3. That's our answer. Have a 2/3 chance. And if we take 2 divided by 3, we will get 0.666666. So we round it to a 7, multiply by 100, and we get 66.7%. Okay. Now, just to connect these two, what if I took the answer to part A and the answer to part B and I added them together? 33.7% plus 66.7%. Look what happens. Oh, 33.3. Shouldn't get ahead of myself. Okay. 3 plus 7 is 10. Carry the 1. 6 and 3 is 9, plus 1 is 10. Carry the 1. Ooh, we got 100%. We got everything. So that's what, if we count everything, we should always get 100%. That's question 6. Chapter 8, question 6, a similar problem to question 5. This time the data deals with a number of credit cards that people have, and again they're broken down by gender, male or female.